Hello and welcome to this afternoon session. I hope you all had a good lunch. My name is Dalibor Topic. I did the Lambda talk yesterday. I work for Oracle. This is the wrong conference, of course, but there is a reason why I use this title slide, because I spoke about JDK 7 updates at Java 1 a couple of weeks ago in San Francisco. And I should also add that I work for Oracle on OpenJDK, in particular as the JDK 7 update project lead in OpenJDK, yada, yada, yada. The reason I put this up is that the motto of Java 1 this year was, make the future Java. And in this project, in the JDK 7 update project in the OpenJDK, we literally do that. So what I'm gonna tell you about here is gonna be the gory details, how we make the nice, not gory, the tofu sausage of the JDK, right? How code goes in and how it all happens and how you can actually play along at home. As with any presentation you've seen from me or from any of my Oracle colleagues, there is a slide like this. What can I say? I'll just leave you a few seconds to read it yourself. There will be a test at the end. Yeah, you're all fast readers, I can see that. Okay, moving on. So, first of all, since this is the first session after lunch, I want to see your hands up if you're using Java 7 today, right? Oh, this is a marvelous picture. I could just end here, right? You all know everything you want to know about it. Wonderful. Okay, so now that we're done with the survey and with the small exercise, I'll kick off the thing with a demo. Given the motto of the last Java was make the future Java, we'll do just that. And I'll speak about the history of the 7 updates, so why they're there, and then how we do them, and what we've accomplished in the first year of doing JDK 7 updates in the open. So let's start with a demo. And you can't have a demo without shells. So what I'm going to do here is, I hope this is somewhat readable, right? I'm going to download the source code for JDK 7 update-dev forest. That's the bleeding edge of JDK 7 update development in OpenJDK. Using HG, that's Mercurial for those of you who use Git. It's like Git, only better on Windows. And I'll just clone this repository, which is under hg.openjdk.java.net/JDK7u/JDK7u-dev. This is going to go out and, clone it, create a bunch of files. All right, it's there. Excellent. Something happened. The network actually works. And there isn't much source code here, is there? Oh, there is a get source file. Okay, let's run that. So the way the JDK 7 forest is set up, we have a top-level forest to Mercurial, and then we have for all the components like HotSpot or Corba or JAXP or language tools or JAXWS, or JDK code itself, separate Mercurial forests. So the script basically pulls all of this together into a nice little repository. And because this would actually take a while, the JDK is big, as Mark likes to say, I'll just switch over, like in a cooking show, to a different place over here, where I've actually already prepared a JDK layout. And you can see here is, JAXP and HotSpot and JDK and lang tools and everything and make files and stuff. So now that we have the code, we have to build it. In order to build it, we have to do a bit of voodoo, a bit of a magical incantation. So we tell the build system where to find the JDK we need to build the JDK itself. Because, of course, the JDK is chock full of Java code. You need a Java compiler to compile all the Java code. You need to tell it where to find a Java compiler. So we do that here, and because I'm a German, I also tell it to use the C locale, yada, yada, yada. All right, and then we hit make to make the future Java. And then there is a bit of sanity checking, stuff happens, things scroll on screen. It starts bootstrapping Java C and all of that stuff. It starts building Java C itself, so, all of this starts happening. On a reasonable machine, this takes about 20 to 30 minutes. I could just spend the rest of the talk watching this and telling you what's being compiled, but it would be boring. In particular, it takes quite a bit longer on this machine because I have a corporate antivirus thing running. So let's not do that, right? Watching code compile is kind of boring. It just shows that you can easily check code out, build it yourself, and get to JDK you build yourself. Now, instead of compiling, this code yourself, you can just go to a website called JDK7.java.net. And there, pulling the crank, you will find, once it loads, a bunch of links, in particular to downloads, once it loads. Oh, all right. The nice thing about this is, of course, I have this on a slide. So I'll just switch to that. So once it loads, it looks a bit like this. There's a JDK7 Java web page. You can click on a download link. It'll bring you to early access developer preview downloads of the JDK7 in development. So if you want to follow the bleeding edge of the JDK7 update development, but you don't have the time or the passion, or if you're on Windows, I mean, building on Windows just as much fun, you can just go here and download the builds for Windows, for macOS 10, Linux, Solaris on Spark, x86, and last but not least, Linux on ARM. So for those of you who haven't seen it, up on our booth in the exhibition area, we also have Raspberry Pis as a competition kind of thing given away. So you can actually go and download the latest and freshest 7 updates to run little devices. All right, so this is what you do when you don't want to build this stuff yourself. And the question is, now that we're doing these things in the open, why do we do these things in the open? So why do these people sit on the floor and write code? As with any OpenJDK project, the 7 updates project has a specific goal to deliver something. In our case, the goal is to develop updates to JDK7, and you can find all this on the JDK7 update website. And that means that, contrary to the JDK7 project itself, which had the goal to deliver a reference implementation for the Java platform, the Java 7 platform, we are actually only focused on updates. This means that rather than having a couple of years to develop, one release, we actually work very differently. We deliver a couple of releases per year. So our processes have to be different. Our way of development has to be different from our RI project. And the way this got started was in the run-up to Java 1, to Java 7 launch. Henrik Stoll, who is an Oracle spokesperson and a senior director for Java IC platform, announced on his blog that Oracle will be moving to OpenJDK as the official Java SE 7 reference implementation. And that's a step that before this move only happened, say, with Glassfish becoming the official implementation for the EE spec. So this was a pretty big deal for people implementing Java SE. And having announced that, you can actually now go to JDK7java.net on the Java SE 7 RI link and download that reference implementation from last year. Reference implementation is a very specific term in JCP terminology. It sort of is similar to the ore kilogram in France, in Paris, in the museum, right? The one you compare against. When you go to your local fish market to buy fish, you don't go to Paris to weigh it, right? You use something that's actually weighed against it. So in that sense, this reference implementation, it's based only upon the code in the 7 project in OpenJDK. It has some binaries for Linux and Windows, but those binaries are primarily for use by implementers of the Java SE 7 platform specification, so they're recommended for reference only. In particular, don't get updates, right? It's a reference implementation. You don't go to Paris to paint the kilogram new because this year's cool color is green, right? You don't touch a kilogram. It's good the way it is. And that means that for updates, we had to have a different way to develop these things. We had to have a project for them. So, okay, we released 7, great, press release. One of many press releases mentioning OpenJDK from Oracle, good stuff. And then we started to create a new project in OpenJDK to do this development in, right? Because we didn't want to just reuse the existing 7 project with its own processes, because we had to do something different. For the first time doing the updates in the open meant we had to think a bit harder about how we want to develop the project itself, how we want to interact with the community. And so we started by creating a website, creating a mailing list, JDK7U-dev, and inviting the community to talk with us about the processes and, develop those as we go. So we have a repository. We actually have many repositories. You've seen a couple of those before. We do development in 2 lines. The -dev line is really the bleeding edge. The JDK7U is our master forest. That's typically the code for next release. Once we get to a point where we're ready to stabilize for a specific version, then we create a special forest for it. So for example, once we're ready to stabilize for 7U6, we create a special 7U6 forest for it. And development traffic, as you would imagine, open source projects takes on the mailing list, yada, yada, yada. And the website has all information about processes, a QA, and status updates. So in practice, of course, these updates are developed by people, actually by quite a few people. Most of them came into the 7 updates project from JDK 7 already, of course. But over the past year that the project has existed, we have continued to attract new people from Oracle, from Red Hat, from IBM, and so on, to join the project and start contributing fixes into updates. You can see that today there are more than 200 individuals with some role in the project, either as reviewers or committers or authors. And OpenJDK author is kind of the basic level you start at when you're not ready to push changes yet yourself. In the first year, we had, on average, about 200 commits per month. These are statistics from a website called olo.net. So if you go there, search for OpenJDK 7, you'll find updated data. I'm sure this is from last August, when the project was 1 year old. Of course, commits means, in this case, in Mercurial, even the tag is a commit. So it doesn't quite reflect all the bug fixes. It kind of overestimates a bit. At the same time, it overestimates the same way for any other project. So the nice thing about Olo, you can compare this against, say, Eclipse or other communities and see how they're doing. You can also see in the way the commits kind of look that at some phases in the project, in particular when we move towards starting to stabilize a release, there is a peak when people start getting the features in, right? Deadline to get the features in, and then the whole thing kind of trails off, stabilization and so on. The same holds for committers. So in terms of contributors, 7 updates in the first year had seen contributions from 119 different developers. So on average, basically 2-3 dozen people are involved every month in pushing fixes back. And this only paints a partial picture because, of course, the JDK 7 updates for itself pulls code from other forests, from HotSpot, from Corba, from JAXP, and so on. So in a certain way, this is just an aggregate picture. Now, the other big thing is we're producing code. Okay, we do stuff. But since we're an OpenJDK project, we have to do this in the open, right? So as an open source project. And one of the nice things introduced last year into OpenJDK are the new OpenJDK bylaws, which mandate that projects operate in an open, transparent, and meritocratic manner. And of course, the alignment with those governing principles is monitored by the governing board. John Dimovic, who spoke with the keynote today, is actually a member of the governing board for OpenJDK. So he's looking over my shoulders as I do this, right? And since we figured we're doing this for the first time, right, in the open. On the 6 series, there is an OpenJDK 6 project, but it has pretty much nothing to do with Oracle JDK 6. Right? It's a very different code line created from OpenJDK 7 a couple of years ago. For 7, with 7 updates, the OpenJDK 7 update code in OpenJDK is actually the basis for the Oracle JDK 7 update releases. So we add some things, we throw some things away, but ultimately, if you fix a bug in the open source part, it goes into a release from Oracle side later. And that means we had to actually think differently about development because we had to think about how to engage a community, how to make it possible to provide us with feedback, with features, with bug fixes from the get-go. So what we did was to start to have a discussion about projects immediately as soon as the project was created to discuss those processes. And we started off with some ground rules. And the first one is, of course, since we're doing this for the first time, we figured whatever process we come up with, they're going to change as we learn more about how to do this well. So the first rule was that process can change after public discussion because you don't want to surprise anybody with a change that wasn't discussed publicly. The second rule, ground rule, was to steer development of new things towards 8 first. And the reason for that is, again, if you look at how long it takes to develop something like JDK 7, multiple years, versus having to deliver updates multiple times per year, say for 7 updates. The reason for that is that what you want to get as fixes going into updates are good changes that have been well tested through somewhere else, right? That are not in any sense controversial. So we use JDK 8 as our place to steer development to first, and then once the change is in 8, once the change has been going through some testing in 8, then it gets backported into 7 updates by the developer developing the change. This is actually quite an improvement for developers doing updates, so it means they can reasonably quickly, get things into 8 and then flow them back into 7 updates. But it also means that we never get to forget bug fixes, so we don't get to a point where, we're a few months away from shipping 8 and we're almost done except from all these hundreds of bug fixes that have been forward ported. So that doesn't happen. This way we ensure that if we fix a bug, it gets fixed in both in 8 and in 7 updates. Since we have multiple forests, we've introduced a new role called maintainer in 7 updates. And maintainers basically act as traffic cops. So maintainers, that's me, that's my colleagues Sean Coffey and Edward Wendelin. We act as traffic cops when it comes to changes coming into updates. We look at any change requests coming in, see if it makes sense for the updates, see if the review threads have included positively, if there are any applicable changes that that need pointing out, like say changes to Java doc, we discuss them and so on. So for us as maintainers who take care of being the traffic cop of approving or not approving changes, the changes designed for the updates have to be publicly reviewed and approved, of course. And those approves are all done centrally on the JDK7U-dev mailing list. So if you want to follow along, say, if you're interested in seeing when the next version of HotSpot is being integrated into 7 updates, all you have to do is subscribe to the JDK7U-dev mailing list and follow along with the traffic. And you'll see the request coming up from one of the HotSpot maintainers. You'll see me or Edward or Sean discussing it, and then eventually approving it after testing. But the reviews don't have to be done centrally, simply because when we have 200 changes coming in per month, and all of them would have to be reviewed on a single mailing list, that would just overwhelm, in terms of traffic, everybody subscribing to it. And it's also much nicer to review things within a circle of experts, within their own mailing lists. So for example, the macOS 10 port changes get reviewed on the macOS 10 port development mailing list. All right, there's a few more rules about things maintainers can do to just move things along nicely. And of course, last but not least, changes for updates have to be plausible. They have to make sense. We don't want to have random kind of fixes in there. And since we're doing code review in the public, we spent some time figuring out how to make this work well for 7 updates and code coming in from 8. And one major thing we noticed is that a lot of fixes are applicable simply because 8 starts from the same code base as 7 did, to 8 as well as 7 updates as they are, without having to be modified in any way, which is great. In that case, the code has already been reviewed in JDK 8. There's been a review thread for it. It's been tested in 8. So if the change is an unmodified change set from 8, it gets, it can get approved without additional reviews for 7 updates. A maintainer can request additional reviews, of course, but it doesn't have to. Now, if there is a fix being backported from 8 that requires modifications, for example, the make file has changed, or there was a cleanup in some API or something like that, then of course you want to have an extra review. So in those cases, there is a slow path or slightly slower path where we require a review, where we require an additional pair of eyes to look at the code to make sure that the proposed change is actually suitable for updates, and as it is proposed, that it makes sense and doesn't break anything. So changes basically for regular forests will require at least 1 reviewer, for at least 2. And of course, we want people to share their backport plans with original authors. And if you're in the list, this is what you basically see pretty much every day coming in, a request for approval for a backport, for a bug fix, with the pointer to the bug ID in a bug database, with the change sets, with a change, with a web ref, that's the tool we use to review code, and the corresponding review thread. Another piece of code that's slightly different is bulk changes. I mentioned before HotSpot and Corba and these things. They're not developed in 7 updates per se. They come from different OpenJDK, or in the case of Corba and JAXP, Glassfish projects. So in that case, it doesn't make a lot of sense to re-review these changes again in 7 updates. So we consume these changes in bulk. And again, maintainers play the role of the traffic cop. And this is what a HotSpot integration request looks like. This one was from a couple of weeks ago for a new version of HotSpot, which has the pointer to the code being integrated, a list of bugs that are being addressed in this bug integration. So you, as somebody following along development, can actually see what's happening, what's being planned to get integrated. All right, so if you have a bug fix yourself, where do you go? Well, if you don't know, please ask on a mailing list. And we will likely tell you to go somewhere else first, right? Like go to 8. Or it's a hotspot change, go to hotspot. Or it's a corporate change, go to Glassfish. And then get your fix integrated and accepted there. And then once that's done, come back to us with a backport request. And of course, not all backports make sense. So if you change an API that doesn't exist in 7 updates, we're probably going to refuse that. But most of the developers working on the project and coming new to it actually know a great deal about providing good requests and good fixes. An example that we did over last year was integration of the macOS 10 port. So in the beginning, this started out as a special BSD porting project, and then it became a macOS 10 porting project focused just on macOS 10. And then last year, we created a separate integration forest for it to sort of bring the macOS 10 porting project close to the JDK 7 update mainline, kind of minimize the risk while it gets closer and closer. We integrated this into the 7 updates early in this year. And once the port was integrated, it was forward ported to 8. So this was different from what I said before. In this case, the change was so big and would have required too much work to go backwards, to go from 6 to 8 and back. So that we went through 7 update first. And all this is now in 8 and being maintained in 8 as well. So if you have Mac fixes now, go to 8 first, right? So what do we have to show for all this, for all these processes and code and everything? We have releases. We have done a couple of releases in the open, fully in the open from the start till the end. We started with 7 update 2. That was the first ever JDK release done from the beginning till the end in the open, released in December last year. It included a bunch of features, new hotspots, new operating systems, yada, yada, yada. Then a couple of months later, like I said, we did this on a very, very fast cycle. Every couple of months there is a release. We had 7 update 4. This one was the first release to be done in the open and integrate a whole new operating system port. And this is a really big deal because the JDK doesn't often get ports to new operating systems. The last one, I think, done before that was to Linux back in the early 21st century, right? So pretty big deal. All of it also done in the open, released in April this year. We started to publish the source code bundles as a zip file for those of you who don't use Mercurial and just prefer to get a zip download. Again, a new hotspot version, a new version of G1 that's supported. And of course, with every one of these updates, you also have the regular churn of things. You have updates to components you include, like JAXP. You have the time zone database updates. All of these things happen there as well. Then, the last but not least, in August this year, we released 7 update 6, which completed the work we did on bringing over the macOS 10 port by adding not just the JDK side, which we did in 7 update 4, but also the JRE side. So all the other bits and pieces required to actually have a macOS 10 JRE. It provided a new hash function implementation. And this is an interesting bit that kind of shows the philosophy behind doing updates. So this hash function implementation is in 8 as well, of course. As we said, go to 8 first, bring it back. But in 8, it's enabled by default, right? In 7 updates, it's disabled by default, but you can turn it on. And the reason behind that is, of course, an alternative hash function implementation may actually change things for you, may result in different performance characteristics, for example. So in order not to break anything that users expect, we make that an optional feature for 7 updates and make it a default one for 8. All right, so that has been the releases we've done fully from start to beginning in OpenJDK. And of course, that also means as we continue, you can all get involved. In particular, you can help us by trying out these developer preview builds and reporting any issues you find, any bugs you find, right? There is only so much we can test. In particular, there is a lot of code that isn't open source out there, that's internal, right? That we couldn't even possibly have access to. There is this part of the iceberg below the waterline. So, if you're interested in ensuring that 7 updates work really well, for any Eclipse code you have in particular, for example. Make sure to try out the preview builds and report back to us any issues you find as early as possible so we can fix them as soon as we can. And of course, if you're interested in more of the gory details, if you're interested in following along as updates get developed as a patch-by-patch play, please do subscribe to the main list and participate, show up, and go from there. And that's all I have for you for today. I hope right on time. If you have any questions, I think the next speaker is actually only 5 minutes. See me outside or see me at the Oracle booth today or tomorrow morning. Thank you so much.